Welcome back to the deep dive. We're picking up right where we left off, getting into Ouroboros Leios. We recently unpacked Ouroboros Praos, remember? And now we're looking at what feels like the next really big step for Cardano.
Yeah, building on those foundations like classic, Praos, Genesis.
Exactly. And Leios seems laser focused on, well, performance, right?
Yeah.
Unlocking a whole new level.
Precisely. You know, where the earlier versions were really about getting that secure, decentralized base solid, Leios is engineered to massively boost transaction throughput.
So handling more data, more complicated scripts, just way more transactions per second.
Way more, yeah. And think about Perez that was enhancing the peer-to-peer network layer. Leios digs right into the core, the consensus mechanism itself.
That's a great distinction. And as we touched on with Perez, the current bottlenecks, the ones in Ouroboros Praos, they aren't necessarily because nodes are running out of steam hardware-wise.
No, not primarily. It's more fundamental. It's baked into the structure of the consensus algorithm as it stands.
Right. So even with amazing hardware, tons of bandwidth. Yeah. The way Praos processes blocks one after another sequentially, that creates a kind of speed limit you can't avoid.
That's the critical point, yeah. So today, our mission is really to unpack how Leios plans to, well, smash those limits.
Okay.
This isn't just tweaking things. It's a pretty fundamental redesign. And when you think about the network improvements Praos brings, Leios layered on top of that, that could be a serious game changer for what Cardano can actually do.
Okay, let's start there then. Let's really pinpoint the why. What are the specific inefficiencies in Ouroboros Praos that Leios is designed to fix?
Well, a big one is block diffusion. So in Praos, you get a new block roughly every 20 seconds.
Right.
But the time it actually takes for that block to get across the network to diffuse is much shorter, maybe around 5 seconds on average.
So hold on, there's like 15 seconds of waiting.
Yeah.
In every 20-second cycle.
Pretty much. Yeah, a big chunk of idle time, like 75% of the interval where the network isn't actively producing or fully propagating the next block's potential.
Wow, that sounds inefficient. It's like having super fast internet, but only using it for a few seconds every minute.
That's a good analogy. And even during those 5 seconds when the block is spreading, most nodes aren't really maxed out. Only the ones directly involved in validating or relaying that specific block are working hard. It's very linear. You know, block goes from A to B to C sequentially.
Okay, right. And this is where Leios takes a completely different path, doesn't it? It introduces this idea of a concurrent blockchain structure. What does that actually mean?
Yeah, think of the traditional blockchain like Praos as that single lane road. Every block has to wait its turn. Block B needs block A finished, block C needs block B finished, strict order.
Right.
Leios is more like building a multi-lane highway. It allows several blocks to exist sort of side by side at the same level in the chain.
Okay.
This breaks that rigid dependency. So nodes can actually work on different blocks and the transactions inside them in parallel, concurrently.
So instead of node X waiting for block A to be done and fully spread before it can even think about block B, multiple blocks can be in progress across the network simultaneously.
That's the core idea, yeah. Sounds great for throughput, right?
Absolutely. It sounds like you could just process vastly more stuff.
You could, but naturally running things in parallel introduces, well, new challenges. You have to ask, what happens if these parallel blocks try to spend the same money?
Right. Conflicts.
Exactly. Conflicting transactions. And how do you eventually stitch it all back together into one consistent ledger history that everyone agrees on?
Yeah, that seems crucial. If you've got block X spending asset 1 and a concurrent block Y also spending asset 1, how does Leios figure that out?
Okay, so Leios uses what the researchers call an optimistic approach. It kind of assumes or hopes that most concurrently processed transactions won't conflict.
Optimistic, okay.
And it uses sharding principles, not full state sharding like some other chains aim for, but more like grouping transactions into different input blocks in a way that makes conflicts less likely.
Trying to keep potentially conflicting stuff separate from the start.
Sort of, yeah. So the process looks roughly like this. You get multiple blocks of transactions processed concurrently. Within each block, transactions still have an order.
Okay.
But then when the results from all these parallel blocks are brought together, they get linearized, put into one single final order.
And the conflicts. What if that optimism was wrong and 2 blocks did spend the same asset?
Good question. If that happens, the system has a rule. Basically, first come, first served. The transaction that got into the ordered sequence first is the winner. Any later transaction trying to spend the same input is just discarded, invalidated.
Okay. That sounds like it needs a really clear, unambiguous way to know exactly what inputs a transaction is trying to use, even before it's fully confirmed.
Bingo. And that is precisely where Cardano's extended UTXO model really shines. It's a huge advantage here.
How so?
Remember, in EUTXO, every transaction explicitly states which unspent outputs, which specific pieces of value it's consuming as inputs.
Right, it's very explicit.
And it says what new outputs it will create. It's deterministic. You know exactly what a transaction intends to do just by looking at it. You can even figure out its result before running it, mostly.
Ah, I see. That makes spotting conflicts much easier, doesn't it? If two transactions list the same input UTXO, you know immediately there's potential clash.
Exactly. It makes validating transactions independently, which you need for parallel processing, much, much simpler and safer. You can spot conflicts easily. You can even, to some extent, reorder transactions within a block if their dependencies allow it, without changing the final result.
So EUTXO wasn't just some random design choice back in the day. It actually makes this kind of advanced concurrent approach like Leios possible, or at least much more feasible.
It's a critical enabler, absolutely. Leios really leverages that fundamental design of Cardano. It's not just tacked on.
That's fascinating. Okay, so you mentioned concurrency, and you also mentioned a three-tier blockchain structure. This sounds quite different from just a single chain of blocks. What are these tiers?
Right. It's a key part of how Leios manages the concurrency. There are three specialized types of blocks: input blocks, endorsement blocks, and ranking blocks.
Okay, let's take them one by one. Input blocks.
Input blocks are the first tier. They're created frequently, maybe even multiple per second eventually. And they do what the name suggests. They contain the actual transactions submitted by users.
So these are constantly scooping up new transactions.
Exactly. And each input block points back to a recent state of the ledger, giving it context.
Got it. What's the next tier? Endorsement blocks.
Yep, endorsement blocks. These come next. Their job is to bundle together a set of recent input blocks.
Okay, bundling them up.
And then these endorsement blocks get validated. Nodes are selected using that familiar stake-weighted lottery like slot leaders and Praos.
Right, the VRF mechanism.
Exactly. Those selected nodes check the bundled input blocks. If enough validators sign off on an endorsement block, it generates endorsement certificates. Think of these as proof that a batch of input blocks looks valid so far.
Okay, so input blocks propose transactions. Endorsement blocks validate those proposals in batches. What about the third tier, ranking blocks?
Ranking blocks are the final tier. These are produced less often, maybe closer to the current 20-second interval we have now.
Ah, okay.
Their crucial role is to establish the final, definitive, unambiguous order of all the transactions. They do this by referencing multiple endorsement blocks, effectively saying, okay, these batches of transactions in this specific order are now officially part of the ledger.
I see. So you've separated the tasks, collecting transactions, input, validating them, endorsement, and finally ordering them, ranking.
Precisely. That separation is key. It allows the network to perform these tasks in parallel. Input blocks can be created and processed while endorsement blocks are being validated, and ranking blocks finalize the order based on validated endorsements. It maximizes resource use.
And it means nodes don't necessarily have to process every single transaction instantly to know the overall state.
That's another benefit. They can adopt the state confirmed by the ranking blocks, potentially processing the full transaction details slightly later if needed, which helps with efficiency.
That division of labor really clicks for enabling concurrency. Okay, the big question then. What kind of performance boost are we actually talking about here? What are the targets for Leios?
Yeah, the targets are pretty ambitious. Let's look at a few metrics. Data throughput, how much raw data the network can handle per peer. Currently, Cardano is around, say, 4.4 kilobytes per second per peer connection.
Okay.
Leios is aiming for something potentially around 900 kilobytes per second per peer, a massive jump.
Wow. Okay, what about script execution? Running smart contracts.
Right, script throughput. You can measure this in CPU time spent executing scripts per second of real-world time. Current Cardano is maybe around 2 milliseconds of CPU time per second.
Pretty small.
Yeah. Leios targets potentially 1,000 milliseconds per second, basically utilizing a full CPU core just for script execution per
It's
core.
orders of magnitude more complex computation possible.
Exactly. And when you put the data throughput and script throughput improvements together, the simulation suggests Leios could push Cardano beyond 1,000 transactions per second, maybe significantly beyond, depending on the transaction type.
Over 1,000 TPS. That really does open up possibilities, doesn't it? Complex DeFi, high-volume applications, things that just wouldn't work smoothly now.
Absolutely. It moves Cardano into a different league in terms of potential use cases beyond just simple transfers. Think complex financial instruments, maybe even some types of gaming or social media elements, high-frequency microtransactions, things that are tough on the current system.
Okay, those performance numbers are genuinely staggering. But, and this is always the crucial but with Cardano, what about security and decentralization? Making things faster is great, but not if it compromises the foundations.
Absolutely paramount. And the Leios design is very explicit about maintaining those core properties. It's still built on the Ouroboros Foundation, designed to resist attackers controlling up to, 50% of the stake. That hasn't changed.
So the security assumptions are the same.
The core security principles, yes. For instance, they're keeping that roughly 20-second interval for the ranking blocks, which provides that final settlement layer. The protocol still has carefully timed stages within that interval to ensure security.
And things like the endorsement process.
Right, the endorsement thresholds needing a certain amount of stake to validate endorsement blocks that adds another layer of security. It ensures input blocks are properly vetted before they even get considered for final ordering.
What about decentralization? Does running Leios require supercomputer nodes?
That's a key consideration. The goal is to maintain Cardano's decentralization. Yes, resource requirements will likely increase compared to Praos. You need more CPU, maybe more memory, definitely handle more bandwidth to achieve these speeds.
Sure, makes sense.
But the design intention is that it should still be manageable for the current range of stake pool operators. It shouldn't require, massive data center infrastructure just to participate. The underlying stake-weighted VRF selection for leaders remains, and it's still fundamentally Nakamoto-style consensus.
Yeah.
Open, permissionless participation is still the goal.
Okay, so boost performance significantly, but without sacrificing security or centralizing the network.
Yeah.
That's the tightrope they're walking.
Exactly. It's a complex balancing act.
So where is Leios right now? Is this rolling out next month, or is it still further out?
Oh, it's definitely still in the research and development phase. It's a major undertaking.
Okay.
There's a lot of work happening. Formal methods are a big part, mathematically defining the protocol, proving its properties, validating it rigorously.
Making sure it actually works on paper before building it all.
Precisely. And extracting specifications from those proofs to guide development. Then there's extensive simulation work. They're using both Haskell, which is Cardano's main language, for detailed mini-protocol simulations.
Yeah.
And also Rust simulations, aiming for more realistic, large-scale network testing. Especially important now to see how Leios interacts with the kind of network environment Paris aims to create.
Makes sense. Comparing the simulations, too.
Yeah, cross-simulation analysis is crucial. Making sure the Haskell and Rust models give consistent results, finding potential limits, validating the thresholds needed for things like endorsements.
What else?
There's delta Q analysis that's about modeling network performance, predicting latencies, finding bottlenecks in the data flow itself, and of course ongoing improvements to the tooling and infrastructure needed to actually build, test, and deploy something this complex. Docker support, topology generators, cost models, all that groundwork.
It sounds incredibly thorough. A multi-pronged attack on the problem. What's the rough roadmap look like?
Well, in the short term, it's about refining those models, making the simulations even more accurately reflect real-world conditions, including the effects of Paris. Midterm, the idea is to start integrating the outputs from these Leios models into other Cardano tools and simulations. Get a better picture of overall network health and performance when you factor in Leios and Paris working together.
Saying the whole system.
Right. And then long-term, the insights from all this research, the simulations, the modeling that will inform future upgrades to the consensus protocol itself, maybe things like data compression techniques or more dynamic ways to handle transaction fees, all within this new Leios Paris framework.
So it's a journey. For listeners who are really keen to follow along, maybe the more technical ones, where can they go to learn more?
Good question. There are definitely resources. The official Leios documentation website is probably the best starting point for an overview.
Okay.
For deeper dives, the IOHK Research Publications section often has the academic papers. The Cardano Weekly Development Reports usually mention progress on consensus R&D.
Right, those are useful.
And for the really technical folks, the Ouroboros Leios GitHub repository is where you can find discussions, maybe some code snippets or development branches eventually.
Excellent. This has been really illuminating. It's clear Leios isn't just an upgrade. It's a fundamental rethink aiming to solve those core scalability problems we see in many blockchains.
Definitely.
And it's fascinating how it seems designed to work synergistically with the network improvements from Paris that we discussed previously. It really feels like an evolution from where Ouroboros started with Classic. Quite a leap.
It really is. And for you, the listener, trying to get up to speed quickly and deeply on this stuff, Leios offers a really compelling answer to those throughput limitations. It's not just about more power. It's smarter design at the consensus level.
Yeah, the aha moment for me is really seeing how that parallel processing, combined with the three-tier structure input endorsement ranking, lets Cardano potentially break free from those one block at a time sequential limits,
Yeah.
especially on top of a better network layer from Paris.
Exactly. Decoupling those tasks, collecting, validating, ordering, allows for much more efficient use of all the network's resources while aiming to keep it secure and decentralized. It creates this potential synergy with Paris's P2P enhancements.
So here's the final thought to chew on. Considering Leios' focus on concurrency, on really maximizing what the network can do, and building directly on those Paris network upgrades we talked about, how could this fundamentally change the game? What kinds of applications, what scale of activity could we actually see on Cardano in the future if they pull this off while keeping that security and decentralization intact? That combination, that's definitely something powerful to think about. Thanks for joining us on this deep dive.